Hello everyone, this is Shashank, and today we are going to discuss problem E, choose 2 and eat 1 from the Add Code a Beginner contest 282. This problem is based on minimum spanning tree, which is a very important algorithm, and it is asked quite frequently in many online assessment and coding and interviews. So first we will look at the definition, then we will try to come up with solution of this problem, and later we will do the coding part. So what is a spanning tree? A tree where the nodes are connected with all the other nodes directly or indirectly and does not contain any cycle or self loop is a spanning tree. And what is a minimum spanning tree? The spanning tree whose sum of edge weight is as small as possible. So looking at the example here, we have three nodes 1, 2 and 3 which are directly connected to all the other nodes with edge weights 2, 3 and 10. Now drawing out all the possible spanning tree of this graph, here we have three spanning trees. Here in the first case the total edge weight is 5, here the total edge weight is 12, and in this case the total edge weight is 13. So the least one is this one, so this is the minimum spanning tree in this case. And which is the maximum spanning tree? This one, with the sum of edge weights being 13 here, this is the maximum spanning tree. Now looking at another example, here we have four nodes 1, 2, 3 and 4 which are connected directly with edge weights 5, 9, 7, 4, 1, 2. So drawing out three of the all spanning trees, here we can see that in the first case the total sum of edge weight is 13, in the second case it's 17, and in the third case it's 20. So the minimum spanning tree in this case is this one. And there are many other spanning trees for this graph, but the minimum one is this with the sum of edge with 13. Okay, looking at the problem statement, a box contains n balls each with an integer between 1 and m minus 1 written on it, and the series of operations are: we first choose two balls arbitrarily, then get a score equal to the remainder when x to the power y plus y to the power x is divided by m, where x and y are the integers written on the two balls. Then we choose one of the two balls, eat it, and return the other one to the box. We have to maximize the possible total score. So we can treat this problem as a maximum spanning tree problem, and the n balls as n nodes, and the value remainder when x to the power y plus y to the power x divided by m, where x and y are the integers written on the balls, as the edge weights. So this expression can be the edge weight. Also the same can be concluded from the problem constraint here, where n is less than 500. So obviously we can calculate all the edge weights in O n square time complexity. Now looking at the example here, the first example says the value of n is 4, the value of m is 10, and the value written on the balls are 4, 2, 3 and 2. Okay, so drawing out the graph for this example, the nodes with value 4, 2, 3 and 2, and calculating the value of x to the power y plus y to the power x mod m can give the value of weight of all the edges. So in this case, the after calculating the value of edges is 2, 8, 2, 7, 5 and 7. So by Kruskal's algorithm, what we have to do in this algorithm is we have to take the edge with the maximum value first. When we are trying to maximize the answer, we have to take the edge with maximum value first. So among all of these, the edge with the maximum value is 8. So we will connect 2 with 2 with the edge 8. So we are connecting the balls nodes with edge 8 first, and then which one is the second largest, so 7. So we will connect the edge with weight 7. Here you can see this edge has also the weight 7. You can also connect these, the answer will not change. After this, these balls are connected. After this, we see the next, so the next one from the remaining maximum from the remaining one is 7. Also we can see that we cannot connect this and this again, because in a spanning tree the cycle is not possible. So assume if there is a cycle in spanning tree like this. In this case, uh, no ball is thrown out after using. Suppose we pick ball 1 and 2, and we throw out ball 1, and then again if you connect 3 and 1, then this is not possible because we threw the ball 1 previously. So this is a contradiction, so cycle is not possible. So we cannot take these edge connecting 2 and 3. So again after that, which is the maximum, so it is 4 and 3 with edge weight 5. So we connect this 5. Now the all the 4 nodes are connected with a total sum of 20. So answer in this case will be 20. So I hope you have guys understood the solution and how I am going to make the solution using Kruskal's algorithm and maximum spanning tree. So jumping to the coding part, we have to find the maximum spanning tree using Kruskal's algorithm. We'll start by taking the input nm and the array a, where the array a represents the value of integers written on the ball. Now in Kruskal's algorithm, we have to store all the edges in descending order, and first we have to pick the edge with the maximum value, add it to our answer, and connect the nodes uh, of the resulting edge. Okay, and then we have to move again to the next maximum, and if the nodes are already connected, we have to skip that value and go to the next maximum one. So we are making a vector of vector v to store the value of x to the power y plus y to the power x mod m and the index for the balls. So after running a nested loop to store the value, here we are using the power function binary exponentiation to calculate the value of ai to the power aj mod m and aj to the power ai mod m. And this is the implementation of the binary exponentiation. Since the value of ai and aj is quite large, we have to calculate it mod m. We are calculating it mod m so as the value does not overflow the long, and we are storing it in the vector v uh, along with index I and j. Now since we need the maximum edge first, we are sorting it in reverse order. Now we are using the DSU union find to calculate the to check if the nodes are connected in constant time complexity. So this is the implementation of DSU. Here the find function helps to find the parent of any node, and the union function connects the nodes if they are not connected, and if they are already connected, it returns false. So since we are using path compression and ranking by size, our DSU code will work in constant time complexity. Now for we are declaring an variable answer equals to 0 to store our answer, and moving with the value maximum value first, if the node, and checking if the nodes are already connected. So we will use the find function to get the parent of the first ball and the second ball, and if the parents are not same, then we will add the value to the answer. This means they are not already connected, and we will connect the nodes, and if they are already connected, we will skip it, and we will again check for the next maximum value and check if their parents are same. If they are not same, then means they are not connected, and we'll add it to our answer, and in this way we will get our answer. So let's check by submitting this code. I hope it will be correct. Running. Yeah, so yes, the solution is accepted. I hope you guys understand, and see you.